So hello everyone, I am VIshwas Sundrani and I am Assistant Professor in Department of Mathematics VNR VJIT Hyderabad. So today we are going to discuss some foundation and key concepts related to vectors. So in your curriculum there are topics related to vector differentiation and vector integration. So before jumping directly to that topics, I thought of to cover some foundations and basics related to vectors which you might have studied in your intermediate level also, like vectors, what are the angle between two vectors, and dot product, cross product. So quickly we will see one by one some basics related to vectors, then we will move to the vector differentiation and vector integrals. Okay, so what are vectors? So the term vector is used in mathematics and science to indicate basically quantity that has both magnitude and direction. Okay, the scalar quantity has the magnitude only. Vectors are the quantities which indicates both magnitude and directions. So for instance, if you want to describe the velocity of moving object, you must specify both speed of the object and the direction in which it travels. So some more examples are like force, displacement and acceleration. So these are some basic examples of vectors. Then what is the geometric description of vectors? So generally it is represented by, a vector can be represented by arrow symbol. Okay, and it is by directed line segment. So the length of this arrow represents the magnitude of the vector and the direction in which it points. So this arrow points in the direction of the vector. So this is the direction of that vector. So suppose a particle moves from a line segment A to B, and this is the vector V. So we call this point A as initial point or tail of the vector, and we call this point B as the final point or tip of the vector. Okay, so this is some geometric description of vectors. Next I'll define what is definition of scalar multiplication. Okay, so generally a vector is denoted by some bold-faced letter V, or we can put an arrow above that letter. So in this way we can represent a vector. Okay, and if we can multiply this vector to with some scalar quantities also. Suppose we have considered here C is a scalar. So if we multiply the vector V with some scalar C, so this is a new vector, and this new vector has the same direction as that of the vector V. So CV vector has the same direction as vector V if C is positive. Of course it is required. And if C is negative, then the direction of this vector CV will be opposite to that of the direction of the vector V. So in this way you can multiply a vector with a scalar, and that is again a new vector. So if suppose scalar is 0, then CV becomes 0. If a vector quantity is 0, then also CV becomes 0. So now if 2 points are given, okay, these are nothing but 3-dimensional points. A is having x1, y1, z1 in 3-dimensional space, and B point is having x2, y2, z2 in 3-dimensional space. So the vector A with representation AB is nothing but x2 minus x1, which is first component of B minus second component of minus first component of A. Then its second component is second component of B minus second component of A. Then its third component is z2 minus z1, which is third component of B minus third component of A. So this is the representation of the vector AB, which we have represented by the vector A. Okay, we will see some examples on this also. So if you want to find the vector represented by the directed line segment with initial point A 2, minus 3, 4 and final point B minus 2, 1, 1. So you want to represent the vector with initial point A and final point B. So we can represent the vector AB by this vector A. So this is nothing but A is equal to what? So its first component will be first component of B minus first component of A, which is minus 2, and second component will be second component of B minus second component of A, which is minus 3, third component is third component of B, which is 1, minus third component of A, which is 4. So what we will get? So we will get minus 4, 4, minus C. So this is the vector which represents the line segment with initial point A 2 minus 3 4 and terminal point B minus 2 1 1. So next, if you want to find the length of any vector, you can find. So for two-dimensional vector, so how will you find the length of that vector? If it has two components, say a1, a2, so its length will be calculated as under root of a1 square plus a2 square. So if three-dimensional vector is there, we can calculate its length by modulus of a, which is under root of a1 square plus a2 square plus a3 square, and it is denoted by this mod of a. Okay. So again, these are some basics. If two-dimensional vectors are given, okay, if we are given two vectors A and B, we can add two vectors, we can subtract two vectors like we do for real numbers. Okay, here we have to add by component wise, subtract, you have to subtract component wise. Again, you can multiply some vector A with some scalar C. Okay, so if a1 a2 are two components of vector A, if a scalar is multiplied to that vector, it will be, so the new vector will be ca1 comma ca2. Its first component will be ca1 and its second components will be ca2. Similarly, you can do the same operations for three-dimensional vectors also. If you want to add two vectors a1 a2 a3 plus b1 b2 b3, okay, here it is not minus, this is plus. This is a1 plus b1 comma a2 plus b2 comma a3 plus b3. Okay, this also you can get easily, how you can subtract and how you can multiply the scalar multiple to a vector. Okay, so we'll see next. We'll see this example. In this example, two vectors are given, two three-dimensional vectors are given. You have to find modulus of a, vectors a plus b, vectors a minus b, vectors 2a plus b. Okay, so what is modulus of a? As modulus of a is nothing but the length of that vector. So how we can calculate the length of that vector? So this is under root of square of first component, which is 4 square, plus square of second component, which is 0 square, plus square of third component, which is 3 square. So what it will give me? It will give me under root of 16 plus 9, which is nothing but under root of 25, which is 5. And how you can add two vectors? I'll do one, rest I will leave it to you. Okay, I'll do a plus b. So a plus b is nothing but, this is first component of a plus second component of b, which is nothing but 4 plus minus 2, which is 2, comma 0 plus 1, which is 1, and 3 plus 5, which is 8. So in this way you can do the basic operations on vectors. So here we have added and we have calculated the magnitude of vector a. Now we see what is a unit vector. A unit vector is a vector whose length is 1. So for instance, if these are the vectors I, j and k are all the examples of unit vector. Suppose if you are given any general vector a, which is if you are given any non-zero vector a, you can find a unit vector in the direction of vector a. How you can find? Simply you have to divide. Suppose we are given the vector a, and you have to find the unit vector in the direction of vector a. So how you will find? Simply you will divide this vector a by its magnitude. Okay, so we have divided the vector a by its magnitude. It will give me the unit vector in the direction of vector a. So it can be verified. So here we have assumed c to be 1 by mod a. Okay, so what will be u then? So u is nothing but ca. So c is nothing but, c is a positive scalar because c is nothing but 1 by modulus of a and length is always positive. So u has the same direction as a. How? So modulus of u, if you find, so u is ca, so we'll find the length of new vector u, which is ca. So what is modulus of u? Modulus of u is nothing but modulus of ca. So this is nothing but length of c, mod of c into mod of a. And what is mod c? Mod c is nothing but 1 by mod a. So it will give me 1 by mod a into mod a. So this is 1. So if any non-zero vector is given, you can easily find the unit vector in the direction of that non-zero vector. So next, here we will see the example. You have to find the unit vector in the direction of 2i minus j minus 2k. Simply what I do, I'll find the length of this this vector. Okay, suppose that this vector is denoted by vector a is 2i minus j plus k. Of course you can use the cap because these are all unit vectors I, j, k. So in order to find the unit vector in the direction of a, I will find the length of this vector, which is mod of a, which is nothing but under root of 2 square plus minus 1 square plus 1 square. So this is nothing but under root of 6. Okay, sorry, this is not 1, this is 2k. So here 2 square you have to do. So this is 2 square, which is 4 plus 1 plus 4. So it gives me 9. So under root of 9 is what? Under root of 9 is nothing but c. So what is the unit vector in the direction of this 2i minus j minus 2k? You have to divide it by its magnitude. So it gives me 2i minus j minus 2k divided by 3. So this is our required unit vector in the direction of this given vector. So now this, I think you must have studied the dot product of two vectors in your intermediate. So what is the definition? If you are given two vectors A whose components are a1, a2, a3, and you are given another vector B whose components are b1, b2, b3. So the dot product of AB is denoted by the number A dot B. So what is A dot B? So to find the dot product, you have to multiply two vectors component wise and you have to add it simultaneously. You have to add it. So what is the dot product? First component of A into second component of B plus first component of A plus first component of B plus second component of A into second component of B plus third component of A into third component of B. So in this way you can find the dot product. Now you can note that this dot product is nothing but a real number, not a vector. So for this reason we call dot product as scalar product or inner product. Okay, and this definition we have it is for three-dimensional vector. You can see, you can define it for two-dimensional vector also. So component wise you have to multiply and you have to add. Next we will see, if you want to find the angle between two vectors, so this is important. If suppose that the vectors are now not given to you, you are given the length of two vectors. Suppose mod A is given and mod B is given, and you are also given the angle between two vectors, and you have to find the dot product. Then you can make use of this identity. Okay, so A dot B is nothing but mod of A into mod of B into cos theta. So here it is given that two vectors have lengths 4 and 6 and the angle between them is pi by 3. You have to find the dot product A dot B. So what is A dot B? A dot B is nothing but, so mod A into mod B into cos of theta, which is pi by 3 here, cos of pi by 3. So what is the length of A? Length of A is nothing but mod A, which is what? 4 into what is mod B? 6 into cos pi by 3. You know very well, cos pi by 3 is nothing but 1 by 2. So what you will get? So here, so this is 2 into 6, which is nothing but 12. So A dot B is nothing but 12. Okay. So again, if theta is the angle between two non-zero vectors A and B, why we have taken non-zero vectors? Because we are dividing it by mod A into mod B. So if you want to find the angle between two vectors, you can use cos theta is equal to A dot B divided by mod A into mod B. One simple example we can see, if two vectors are given, you have to find the angle between these two vectors. What we will do, cos theta is equal to A dot B divided by mod A into mod B. So what is A dot B here? So this is 2 into 5, which is 10, plus 2 into minus 3, which is minus 6, plus minus 1 into 2, which is minus 2, divided by, now mod of A is what? Under root of 2 square, which is 4, plus 2 square 4, plus minus 1 square, which is 1, into modulus of B is 5 square is 25, plus minus 3 square is 9, plus 2 square is 4. So what it gives me? This is nothing but 4 minus 2 divided by, this is under root 9, which is 3, into under root of 38. So this give me 2 by 3 root 38. So what is theta then? So theta is nothing but cos inverse of 2 by 3 root 38. So this is not a known value. If you calculate with your scientific calculator, you will get somewhat, this is theta is around 84 degree. You can verify this. So in this way you can find the angle between two vectors. So this is the basics for angle between two vector. Then we will see what is definition of cross product. We have seen the definition of dot product. So generally the cross product of two vectors A and B is a vector itself. So we will see how to calculate the cross product. In order to calculate cross product, you have to take the determinant. In the determinant form, it is easy to calculate. What you have to do, you have to write I, J, K here. Then you have to write the components of A, A1, A2, A3, and the components of B, which is B1, B2, B3. And you have to find this determinant. You will get the cross product A cross B. So basically this cross product gives you the vector quantity. That's why we call this cross product as vector product of A and B. We'll see one example on this also. So this is given vector A and vector B. You want to calculate the cross product. Okay, so let us calculate A cross B. So what is A cross B? This is I, J, K. and here you have to write 1, 3, 4, 2, 7, minus 5. So what it gives? This gives me I into 3 into minus 5 is minus 15, minus 28, then minus j into minus 5 minus 8 plus k into 7 minus 6. So it gives me minus 43i. So this is plus 13j. This is plus k. So this is the new vector. So a cross b in component form can be written as, this is minus 43 comma 13 comma 1. So it's a vector quantity. So what is the difference? So dot product gives you a real number, which is scalar quantity, and cross product gives you a vector quantity. Now we'll come to our main topic, which is vector valued function. So in order to study the differentiation of vectors, you must know what are vector valued functions. So generally a function is a rule that assigns each element in the domain to an element in the range. So vector valued functions are the same, but here the domain is what? Set of real numbers, and here this range is what? Set of vectors. So a function is like this. So from real number to set of some three-dimensional vectors, because we are mostly interested in three-dimensional vectors, we will denote it by v3. Okay, so here it will give, so for every number t in the domain of R, we are denoting it vector valued function by small letter r. There is a unique vector v3 denoted by r of t, and if f of t, g of t and h of t are components of r of t, then f, g, h are real valued functions called the component functions of r. Okay, so this f, g, h, f, g and h are the component functions of vector valued functions r of t, and we can write it like this: r of t is equal to, first component is f of t, g of t, h of t. So all of its components are nothing but real valued functions. So for one real number, so input is t, we will get a vector, three-dimensional vector for different f of t, g of t. So f of t will give me first component, g of t will give me second component, and h of t will give me third component. So in this form, it also you can write the vector valued functions like f of ti plus g of tj plus h of t k. So there are two ways to write r of t. So next, okay, this is the vector valued function given to you. We will see something about this. Okay, you must be knowing what is domain of definition. Domain of definition. So what does it mean? If I ask you, okay, if I ask you some function, I take some easy function. Suppose f of x is equal to 1 by x. So what is the domain of definition for this functions for which the value for which this function is defined? Okay, so for what values of x this function is defined? Almost many values defines this function except one. If you see 0, for 0 this function is not defined. So for a domain of definition for this function is nothing but all real numbers except this 0. Okay, in the same way you can define the domain of definition for vector valued functions. Okay, so what is the domain of definition for vector valued functions? How you can see? Just you have to see its components. So all of its components must be defined for that domain. Okay, so t cube is defined for all real values. Okay, not a problem, all real values. And log of 3 minus t is defined only for when 3 minus t must be greater than 0. Okay, so what does it mean? T is less than 3. So this is the condition on r of t. T must be less than 3. And what about under root t? So under root t is defined for t greater or equal to 0. So what does it say? You must have t greater or equal to 0 and t less than 3. So combinedly it is nothing but closed interval 0 to open interval 3. So this is the domain of definition for this r of t, which is first component is t cube, log of second component is log of 3 minus t, third component is under root of c. So for these values only this function is defined. Other than these values this function is not defined. Okay, so in the same way we can define limit and continuity for vector valued functions. As we have defined limit, we know the limit and continuity for real valued functions, we can define limit and continuity for vector valued functions. So if you want to find the limit as t tends to a of r of t, just you have to find the limit of each component as t tends to a. So these limits must exist. All of these limits must exist. Just a minute. Okay. So if these limit exists, then we can say that the limit of vector valued function exists. Okay, this is one simple example. If you want to find limit t tends to r of t, just you have to find this limit. We'll see how to find limit t tends to t tends to 0 r of t is equal to limit t tends to 0 of 1 plus t cube I plus limit t tends to 0 t power minus tj plus limit t tends to 0 sin t by cos t. Okay, cos sin t, this here it is not cos t, it is t. So what it gives? This is nothing but I limit t tends to 0 of 1 plus t cube is 1 plus this is gone, this is 0, and this is limit t tends to 0 of sin t by t is nothing but 1. So this is k. So what it gives me? This is nothing but I plus k. Limit t tends to 0 of r of t is what? I plus k. We'll see next. How to find the derivatives of a vector function? It is similar like the real valued functions. So dr by dt is nothing but r dash t. We can denote it by this. It is nothing but limit. This is the limit definition of derivative. Limit h tends to 0 of r of t plus h minus r of t by h. In this way you can find. So component wise also you can differentiate it. So basically, if r of t is f of t, g of t, h of t is given, so these are three components of vector valued functions. These are real valued functions, f t, g t and h of t. So r dash t is nothing but f dash t, g dash t and h dash t. So this can be written as f dash ti plus g dash tj plus h dash t k. Here k is there. So now we'll see how to find the derivative of this function. In the same way you have to, I will leave it to you. Okay, what you do, you just differentiate it component wise. So differentiation of 1 plus t cube, you know that that is nothing but 3t square I, and here you have to use the product rule, and differentiation of sin 2t is what? 2 cos 2t k. Again you have to find the unit tangent vector at the point where t equal to 0. So how to find the unit tangent vector? Suppose that you have r dash t. So in order to find the unit tangent vector, so unit tangent vector is nothing but at point 0 you have to find. So basically tangent vector is itself r dash t. So at 0 it will be r dash of 0, and you have to find the unit tangent vector. So you have to divide it by its length. So you have to divide by r modulus of r dash 0. So it will be your unit tangent vector. You can verify this. So next we will see some rules of differentiation for vector valued functions. So if u and v are two differentiable vector functions and c is a scalar, c is some scalar and f is a real valued functions. So what are the rules? So d by dt of u of t plus v of t is nothing but u dash t plus v dash t, same as real valued functions only. And if some scalar is multiplied to a vector u, then its differentiation will be c will be taken outside and derived with multiplied with u dash t. And if a vector function is multiplied to a real valued functions, its derivative will be same. You have, as you have used the product rule in real valued functions, again you have to do the same here. F dash t ut plus f of t u dash t. And dot product also, dot product of two vector also you can find with this formula. First u dash t dot vt, this is the dot product, plus ut dot v dash t. And cross product you can find in a similar way. First u dash t cross vt, so derivative of first vector valued function cross product with vt plus ut cross derivative of second vector valued functions, which is vt. And composite function is given. Okay, u of f of t, how you will find? You will find first derivative of f, which is f dash t, into u dash of ft. Of course f and u must be differentiable. It is already written that all these functions u, v, f are differentiable functions. These are vector valued functions, this is real valued functions, and we have taken c as some scalar. Okay, so thank you very much. So in the next lecture, I will directly jump to your main curriculum, which gives you gradient of a function, divergence of a vector valued functions, curl of a vector value functions, what are rotational vectors, what is solenoidal. All these things we will see in the next lecture. Thank you very much.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.